So I'm Gianluca Gindra, and I'm teaching the data course. The course goal is to understand how to use data. How to use data basically means can mean from the business side of things, from the technical side of things, but is really to kind of show all the tools that we can have to make sense out of data. Right? And that's the target course. But for me, the real course, the real scope is not this, but is understanding the data. So most of the time lies. I think that's the main thing. And what I'm trying to show, like in my course, is all the sort of ways in which data can show different things from what we think that we knew. And what I will hope also to show, like a bit for tonight, but I try to show better in the course, is how you can avoid making the wrong decision with data. Because the way that I see it, if you want to work with data, there is one way to work with data that is the hard way, which is really make the right decision with data. And I think that's really hard, especially in business. But then there is the easy way. The easy way is to try to show that someone else is wrong, that someone else is making the wrong decision, right? And this could be like that your manager maybe is trying to make a conclusion, is trying to make a decision, viewing a report, and maybe you see the data and you can see a bit, no, but listen, there is something that really doesn't make sense here, right? So this is much easier, and hopefully I can give a few flavor about that. How the course is structured. So I don't know, some of you might have seen this slide before. I've customized it here for like the course and try to map what the course does based on this area. A free area, which I think that if you work in data, you should know a bit of this. I mean, of course, some people focus their career on one area, some people focus on a different part. But the free area is like the business side of things. Busters of business analytics, business intelligence, data viz. The IT side of things, like especially the engineering world, the IT world has evolved a lot towards the data engineering side of things. And then there is the mathematics, statistics, and data science and machine learning side of things, which is what has exploded, particularly in the last 5 years or so, and is really what can help make sense out of data. So the first week of the course really start with the business analytics, so to try to see some data, which is data that you might guys have seen like in your company, in your day-to-day world, and really try to challenge those data. Try to see how the data can lie. Try to kind of see what are the ways to visualize and to run experiments. And one example that is seen is that with web analytics, we are doing a few work with Google Analytics, which is kind of an easy tool because it can allow us basically to get to conclusions without being so much technical. So you can just do some drag and drop and you can see some interesting stuff. So this first part really covers like the decision-making and business part of data. Week 2 and 3, and actually, I think we're 3 weeks, so maybe. But anyway, the next 2 to 3 weeks focus on the SQL side of things. SQL, you probably know of, I've heard of it, but it's basically the language of data. Like if you have any data use cases which go beyond Excel, you need to interact in some way, right, with the data. So I really think that it's very hard to work with data if you don't know SQL, if you don't know the foundation of the data. But of course, in 3 weeks, it's quite hard to get to the foundation of it because there can be 1 year of study just for that, but at least it can give you the flavor. And also, I mean, at the end of this part, you can you can finish the part writing simple queries and getting insight and analysis. So basically, learning the language of data. And then again, the way I try to kind of show this, and maybe I try to show a bit later, like in a quiz, is how is easy to get the wrong conclusion of like from data. Like writing SQL queries, I mean, writing queries that interact with data is quite easy. But it's quite easy also to be misled. Like if you run a group by, you're trying to aggregate data and you are not joining the data by the right field, or you're not doing the average at the right level, it's quite easy to think that the data is showing something and then it's showing something else. And I think that's the most important thing for me to try to learn in a course like this, to get the flavor of how things could get wrong. Then there is break actually, yeah, week 4 is a bit again of SQL, but also is also the data visualization part, and I was showing in Chartio and Tableau, tools that some of you might have heard of, and which basically uses the database part. So which, if you have a database, you can either like consume the data directly from the database, which is personally the way that I feel more passionate about it, because the way that you touch the data, you really can do like everything you can do. But it's not necessarily like the best way maybe to present result to your managers or to your client, right? So the data visualization tools allow basically to link with that. And also this allows to show that maybe you can do the same things with the two tools, but you can do in slightly different ways. So data visualization is better to see, but of course is less flexibility because you are not actually going at the lower level of the data. So that's the first half of the course, the first 4 weeks. Then the second half migrates a bit into the statistics and machine learning part. So the machine learning and the data science part. So the foundation of this is really what's done in week 5 is statistics. Of course, it's only 1 week. There are masters in statistics. But the main thing is to give a flavor of statistics, like things like what are the measures that you should check. Like if you kind of see distribution, like the sales report from your company, like the first question could be, what's the average sale in this month, or like the average value of the product that you've sold. Like the first question normally that people ask is the average, or like the trend. Statistics hopefully can show you that the average is only one summary like indicator, which in some cases it is appropriate. In most cases, is not enough. So we can see like a median, the distribution, the variance, the deviation, standard deviation. Also to see some basic statistical concept to see how you need to have enough data in order to draw some conclusion from that, like the statistical significance. Like you see the 2 averages are different from 2 distributions. Is it just by chance? Because, I don't know, you've just taken a random sample from data and just by chance you had only 15 cases and all 15 cases happen to be blue and the other happen to be red, just by chance. Or is this like a statistical significance? That means that if you repeat a number of times which is high, like enough, you would get the same results. And this is also what statistics can show. And then the course migrates a bit into the machine learning part, which is using statistics. We're doing coding in Python, even though, of course, this is not a course in Python, right? To learn Python could take much longer. So what we're doing here is to show some templates of Python, and what is required is just to learn how to configure the template, but mainly to learn the machine learning concept. So what it teaches here, the course is like what a project of machine learning does. And generally, it is you want to predict something. Like, for example, I've worked for some time at a company which was predicting house prices, GeoFi. Like we were getting a database of data points like the crime rate, economy, the hospital, the schools, and then all the property prices. And given some data points, we had to forecast house prices. Like, so in that scenario, the machine learning project means, okay, we get a location, we need to know the price of that house, giving a certain input, right? And so we can show the process of what are the steps that you need to do, and we see that the main time-consuming effort is actually very often not the statistics part, but is the data preparation side. Because it takes a lot of time, especially like in the real estate domain that I was mentioning, like a lot of data was open source or coming from different sources, so was not clean, was not made. So you need to have, but also company data can come web logs from the mobile utilizations or customer logs or whatever. So there is normally like a lot of preparation and then a lot of ingestion. So this part is, in my experience, at least one that is taking most of the time. And then the last part is to actually decide what is the shape of the data and to run the model. And Python is great because there's already a lot of libraries. So you don't need to be like a developer. You just need to learn to do some scripting. And you don't need to even to be a statistician. You just need to have a grasp of what you could do wrong, right? What is the flavor of the argument, how you configure the argument. But you don't necessarily need to have a deep level understanding of all the details of like those arguments. And then the last part is a project of data analysis or machine learning. So it's up to whoever does the course to decide. Some people want to focus more on visualization, on like SQL, or on machine learning. So that's just to give you an idea. There was a slide that was meant to show us a bit of my background. For some reason it wasn't shown, so I'll just try to. Some reason it was hidden. So I'll just try to show here. Then I want to show some puzzle, which hopefully can give you a flavor of how data can lie. So I should have done that before, but anyway, about me. Currently working for a startup, Creative AI. We are doing artificial intelligence for content. So basically, trying to recommend content for companies to post on social media. So from one side, we are building a big database of Instagram, Twitter, and Facebook content. And then we have a machine learning algorithm, which is matching the content with the business. So if you are, let's say, a business, that you are some restaurant here in London, and you want to see what are my competitors, or maybe what are restaurants similar to me in Seattle doing, and you can get suggestion on content that was successful in terms of number of likes or posts in relation to the followers, and you can get inspiration of that and hopefully post similar things and get engagement from your customer. I've worked at Groupon most of my career in data, in which I joined in 2010, which was still CTDL, which I basically I've grown the BI team from scratch, started from a bunch of Excel reports based on CSV, and then evolved that solution toward a more scalable solution with data warehouse and front-end tools. And then I was mentioning I worked for a while for a startup which is doing real estate analytics. The thing of my profile that I've never specialized in one vertical. So I've seen the 3 area business, IT, and the machine learning. I decided never to specialize in one because mainly I liked to get a flavor of all. If I was working in a sector in a vertical for too long, I was getting bored and wanted to do something else. So that's also what I find it interesting to learn. Just one more point on this part, and then we can do a few examples. So on like this side, because the data world, especially now, is quite of a large world, right? And what's the danger of just focusing on one of these verticals? Like, there are people that, so for example, if you focus just on this green side here, right? Like you're just doing a BI. Let's say that you are an expert of Tableau, right? You are a manager, you are getting all reports in Tableau, and you are very expert at making the dashboard or using the dashboard, right? But you don't know this, right? What's the danger of this? Someone has a thought, has an idea. If you forget a bit about the technical thing.
The data is not representative of what's going on.
For example, could be a case. Any other ideas? There are a few things here, but one example also could be, yes, certainly the data cannot be like representative of the data, can also be wrong, like because you don't know exactly. So you are only seeing the surface layer, right? You are just seeing the nice dashboard. Maybe some analyst has presented in a very nice way, and you see reports like revenues of your regions have grown to like a certain extent, right? But how are these metrics computed? Like you just see the top measure, like you just see the revenues, but those revenues maybe are generated from products that are sold, and maybe the products are refunded. Like for example, you see the report on refunds, right? And you see, okay, the percentage of refund is 5%. It is a very nice report. But then you can start challenge, okay, but how is the refund computed? Is the refund of a product sold in the same month, or I'm subtracting the refunds of a product I sold 6 months ago? It can be two completely different metrics, right? And even sales, if you have a report on like new business, let's say that you are a company who wants to target new business because you have a target to expand your portfolio, right? And you have a nice dashboard which is showing the percentage of new business, and you might try to draw conclusion out of this dashboard. But then how is new business the metric? How is that computed? What if you had a partner closed some time ago, and then you worked a second time? Would that count as new business as well? Or if you worked 5 years ago, maybe you would say yes, right? Because that client was lost and I have regained. But if maybe it was just 6 months ago, not, right? So if you just see this layer, like you might lose the detail of how the data from the bottom is aggregated at the top. And here, like this layer, I mean, I think probably the one I feel more passionate about, because this is like the data. So if you like data, you must, in some way, I think, love database, because I think that's really the kind of home of data. You can do pretty much everything, right, with that. But there are some limitations here. So I think that if you are smart enough or precise enough, you could get decent conclusion out of here, but then you can lose a bit the touch, right, of the meaning out of data. So if you decide to develop a career up to here, also there can be path purely IT department oriented, that you might work in database, you might be an expert of performance of databases, but what those tables mean, right? I mean, this could be quite technical careers, and there are some careers in the middle, like if you are doing data modeling, maybe you are doing a bit of a bridge between how the data is stored and how that. So that's good, but that's not enough, right? And if you're just doing, let's say that you need to run a predictive model, and you are very good at statistics, and maybe you also know how to use the tool. But let's say, okay, let's forget about business case because we're doing predictive. But let's say that you are not so good at database or storing data. What could be your limitation in this case, in your view? Sorry?
You'd have wrong predicts. You wouldn't know what is causing it to be wrong.
The wrong causes, you mean? Well, in a sense, let's say that you are really like an expert of statistics. In that case, you should, assuming that you are doing your job right, I mean, this part here in theory should assume, right, that you can separate things like correlation and causations. That's the assumption that you have done the job right. I mean, that's the assumption here, that you are doing the statistics part or the prediction part right. But there can still be some limitations, like even if statistically speaking you are sound or correct.
You may not be predicting what the user needs.
Well, yeah, that could be the missing of this part. Actually, that's a very good point. So if you also, I've seen like at Groupon, for example, in some cases we had like a machine learning team which was doing the recommendation of a newsletter. I don't know if some of you is subscribed or was subscribed at the newsletters from Groupon, that basically the ranking of those newsletters is meant to be relevant to your gender, to your location, to your past purchase history. It's not always working as it was meant to be, but at least in theory. And there was a team in Silicon Valley which was building that. And sometimes there was a disconnect between the team, which was very good at building the model, and what the business was meaning, was wanting, like that. People who were actually closing the deal, so who wanted to target certain segments. So that's an example you actually see. So yes, it's true. And in general, if you are too focused on that, you might do nice predictions, but it not be what the business asks. So that's certainly one risk. What it happens if you miss that part? Like, let's say that you are very good at statistics, and you have, let's say, you have a nice flat table. Like, think of my example, a geofile. Like, machine learning engineers had tables with maybe 600 columns with all possible data points, like how many restaurants there are within a 3 miles radius, the best ranking of the school within a certain radius, and the crime rate in the same postcode, all these kinds of. They had a very large file, right? But let's say that they want this, but they don't have this part.
Efficiency of processing.
Exactly. So how to do this, especially with big data and scale, right? If they have like 1,000 data points, like if you are building a model with 1,000 data points, this might work. You must just fit that in memory. So you can use your laptop, you can run Python on your memory. You have your gigabyte of memory, it just runs in memory, and it works fine, right? But what if you have larger data, right? This won't fit in your laptop, so how you can do that? And then even before that, I mean, that nice flat file that you have that's often not how it comes with data, right? So in that case, we had to take data from dozens of sources, like the crime rate was coming from the police forces, the economics from financial sources, the house prices from land registries and others. So we have dozens of sources written, like even the postcode, it kind of seems easy, but even that is different, like the geography can be written in different conventions. Like some people use the postcode from Royal Mail, some other people use statistical boundaries at different levels, and you have to match that. So if you are just doing this part, if you just know how to do this part, the chances are that you don't have the data as you would like to do, right? Unless you do a competition from Kaggle. I don't know if some of you are aware of this website that you receive already the flat file, like you do this is a machine learning sort of competition. You receive a nice flat file, and you need to run the prediction out of it. And normally the volume of data is not huge. So in that type of competition, you might not need that, but why? Because someone else has already done your job, because that's already a fake scenario, right? But in real world, in companies, chances are that you need to start from here. You need to keep this in mind of what the business wants, not to have a disconnect. And then after these two parts are clear, you can build the model. Now, okay, so as I was saying, like one of the main things I was saying, the hard way is to get right things from data. The easy way is to try to understand things that go wrong. So hopefully after a course like this, I mean, maybe you might not be able to get the right way, but at least to try to do to avoid some wrong decision, it should be the target, also to spot easy things that are wrong. And one, I want to show a couple examples here, maybe to get your feedback, if you can get some intuition of how. And that's a real example. Groupon 2011. We had, hopefully we'll be able to see, but so this is the time, right? It was on a few months. And we were monitoring two metrics there. One was visitors. Which is visitor. This can be in different scales, but it doesn't really matter. And the other one is sales, let's say revenues, right? Let's say revenues, but it could be whatever metric related to say, it doesn't really So we see this report. Let's say that we have it bundled, by week or month. And in that period, we had revenue which was growing. Was a phase of Groupon where the company was growing a lot. But then we see, especially in this first part, like the visitors on the website were growing disproportionately. Like was a massive increase, a 20x increase. Even there was a moment in which the Alexa ranking, it's the ranking of a website which are visited are often, the Groupon website was at number 15, was like same as BBC or things like that. But the revenues were growing, were kind of high, but I mean, it weren't still as popular like as other larger companies. So there wasn't this, and that was real data, that was a real case. Why do you think that can happen? Should we conclude like the conversion rate is going low because, product?
No, which is the business model of Groupon?
Okay, sorry, but I should have explained. So Groupon is selling offers, is selling deals. Basically, we are sending a newsletter to buy, for example, a restaurant deal discounted at a certain percentage. So you receive a newsletter, or you go to the website of Groupon, you see dinner at £20 instead of £50, or some massage discounted by 50%. You buy the deal, and then you can go to that restaurant. So it was mostly a daily cycle, but people could buy whatever they want. So there was several inbound channels from email or from a website. But I say this could apply, I think, to other business models as well. I mean, it could be generalized, I think, to other type of companies. So how it could be? I mean, how could that be that the visitors, so the people who actually went into the web page, like that you could go to the page and you can see which offers were live, have grown so much? But the revenues, yes, was growing a bit, but
I don't know, but Groupon might be doing a promotion where they give you, vouchers, so that will get a lot of people in, but they're not actually paying, so you have this big lump, and then.
Could be. It could be like if you have offers that people go and have a product for free. It could have been an hypothesis. Was not the case.
Or they're buying the cheaper deals from the website instead of the expensive ones.
Could have been, but okay. Let's say, it is a fine hypothesis, but let's see that if we see a line on the voucher sold, which is the number of deals sold, we have a similar line as revenues, and so we don't see that.
They're not targeting the right customer, so they're just doing for mass market instead of specific.
So this would mean, if that would be true, would mean that the marketing manager should be fired, right? Because I think that they're spending lots of money to acquire customers, but these are not buying. Luckily for that marketing manager, that wasn't the case. So it wasn't, but it could have been, but in that case, it wasn't. Good question. Yes, there was no bias. There isn't. Let's assume that there are no metrics or no measurement issues. That's actually very data. But it's a good challenge. We should always challenge that.
What time is it? I mean, I don't know.
Let's say that we are speaking. Yeah, let's say we're speaking about months.
Yeah, but could it be that over Easter people don't really buy stuff, but they visit, or Christmas they browse after? So when was
seasonality? Exactly. Yes, seasonality could have been one hypothesis, and in some cases it actually is. But let's say here that also was the case that these time are large enough that you are aggregating, and maybe yes, you might have some fluctuations of that, but these are something else. These are not enough to explain that.
It also depends on what your definition of visitor is. Is someone who's been there for like 1 second on the website, was it?
How we define, it's getting very favorable. So how we define things, these are also the sort of questions that you should always ask of data. We see a measure, we should always think how we start from the bottom up. But let's say that we have 3-4 different definition of visitors, and we have a similar shape. So it's not about that.
Could there have been an attack on the website?
a denial of service attack like a bot, which could have been. And actually, some of these reports need to be filtered by that. We had also some bot controls. But let's say that's not what's happening here.
Maybe the users, they pay later, maybe. So they visit the website, they take what they want, and maybe the offer is to pay when they use the service later.
So that's going into the right direction. I think it is not exactly as you probably have in mind now, but is going in that direction here. And maybe some of you are familiar with marketing. I'm giving a hint. Online marketing field can expand on that.
Is it something to do with the user journey? How many times a user goes back to a site before purchasing?
Again, it is in the right direction, but not, I would say, the user journey in which you would say, like, you are marketing a product, you first view the product, then maybe you have a think and you go back in the next hour, like the next day. So not in that sense of, it's not the traditional sense of user journey, but it's going that direction.
It would suggest to me that there's just something wrong with the product. Say you're doing a good job at getting people to the site and like getting them excited about going on it, but then there just aren't enough vouchers, the product isn't good enough to actually get people to buy it. So for sure some people are, but there's just something wrong and you need to, you know, I'm sure you probably reached out to the people who visited and didn't buy anything to try and understand why. But for me, just suggest the product.
Which, if that would be the case, would it mean that the managers, like let's say, the sales manager, the people responsible for closing the deal, probably they should be fired. Like, so not in the other case that the marketing manager has done a bad job, but the people who close. But again, luckily for the sales manager, they were doing a pretty good job. So there was nothing particularly wrong with them. But could have been.
The pricing for the products might be too low.
The pricing, what do you mean? If the pricing goes low, people should buy more, right?
Yeah, but depends on, if it's extremely low, then it's pointless, you know? You could have like...
Oh, you mean that the revenue, okay, it's kind of similar to the vouchers, like to the point of like that we are selling more vouchers with a very low price. But again, let's see that we measure things like the number of deals sold, and that's again similar. So, and maybe also we check the distribution of the average price per deal, and there might be some fluctuation, but nothing major. So we see it's not that. Let's try to think. I'm trying to give you a hint more on I don't know if some of you is working in online marketing, but try to think more in the online marketing field.
We could look at the acquisition funnel. Maybe we used to get most people coming from price comparison websites, for example, so they are already sort of looking to buy, as opposed to people coming from a media site where they were just looking for information but not really.
That is exactly half of the reason. It's the first half of this scale. And actually, that's a very important point, which means not all visitors are born equal. Right? So if you want to convey, if you have a measure like you have a revenue divided by visitors, like the average, like you say that you do in a month, you sum your visitors and you sum the revenues, you calculate these metrics, you would see that this revenue drop, but not all visitors are born equal because some visitors might come from organic channel, like they might have in mind, like you could tell me like there is a very good deal. Like as my friend, I go to the website, I buy it, and I convert very high because I was interested, I was driven to that. Or I might see a Facebook banner. I might don't want to buy Groupon, but I just see a Facebook banner. I click on that, and then I see the deal. I see, oh, but why they want me to buy this restaurant deal? I just want to browse on Facebook and just forget about it. So the type of customer and the conversion rate, it's a key point in online marketing, right? So the next thing that we should challenge to do this would be exactly to see, okay, let's see the visitors by acquisition type, right? So that's exactly the first half. But in this case, it was even trickier than that. Like that was certainly part of the story, but was only half of that. and I would tell the second one because it would be harder to guess. But let's say that even if we separate, maybe instead of having only one chart here, we have two charts. Like one is by direct traffic, we mean users which visit the website, another by acquired traffic, maybe just one from Facebook and one from Google, right? In this case, if we would have looked at that report, we would have had maybe a bit less extreme, but we would still have pretty much a paradox like this. It would have only explained part of it, and mainly would have decoupled direct channel. And the reason in this case was that not only those visitors were coming from paid channels, so this actually was mainly bought traffic, right? But it wouldn't be so bad if we buy more traffic, but the revenue grows proportional with it. Like given, let's say that we just look at Facebook acquisition channel, right? Only customers acquired by Facebook. Like if we acquire more customers from Facebook and we look only at the revenue from Facebook, there should be some proportionality, right? Maybe it should decrease a bit because the more we spend, we have already done the quick wins and we can't target too much. Maybe there are some efficiency, but there shouldn't be such an extreme thing, right? But in this case, even just looking at one acquisition channel would still be in the paradox. Why? Because in this case, not only the traffic was paid, but the main acquisition channel was not linked to buy deals, but was to subscribe to the newsletter. So if we would have simply looked like what is the visitor of actual deal pages, which means the people who actually see the offer, buy this restaurant 50% discount, like the visitor would probably be like this. Similar to that, like a similar sort of proportions, which means that the conversion from people, maybe there are still some differences, but nothing so big, right? So the conversion from people who view the deal to people who actually buy the deal was similar. But this gap here was newsletter, like people who just subscribe, and Groupon was not even try to convert those customers now. And that goes to that point that was a delay between people visit and between people buy. So in that sense, it was correct because when you run an acquisition campaign like this, you think about the lifetime value from that customer. You want to maximize the revenue for that customer. That's why the marketing campaign was on newsletter. Because if you target on one deal, first of all, what are the chances that you like that deal, that you like that actual restaurant, that you like that actual beauty service? Might be quite low because it's just one specific thing. But even if you like it, you just could buy that. I mean, you might not. I mean, maybe you don't like it. You like it, but you don't buy. You go away, and we don't have your newsletter. So the main thing was to think long term, so to try to get the newsletter, so that you can get a deal every single day. Why? Because in that case, you have until you decide one day that you don't want to receive newsletters anymore. Every single day, you have a chance to be converted. And we don't pay anymore the acquisition channel because sending an email is almost free nowadays, right? You just received it. And so in a sense, these visitors could buy in future, and also that's why revenue was growing, because some of these visitors could buy at some point in future, but not in the same time period. So this was like an example of how data could have been misleading. Any questions? Yeah.
How did you figure it out? That was like newsletters.
Well, actually now I am reverse engineering the problem, but actually I mean it was clear to most people because there was a big effort in the company to because the fact the newsletter had a big revenue was not by chance, right? Because the management wanted to drive that. So actually everyone in the company at a certain level knew kind of that. But if you would have jumped in the company as a junior analyst and you don't know about the strategy of the company, you just see one line of this, the visualization part, and you see it, you could have been misled. So in that case, it wasn't like a real problem at the managerial level, but it could have, it's something that it could have seen. Like, I mean, it was just, it could have shown some paradox there. But the main point here is to show, again, data can lie, so never to trust. If you just see a report, like, and most of the questions that I've had for you are actually valid questions. And it doesn't mean that if the answer was not correct in this case, that cannot be the answer in just some other case, like challenging how we define like visitor, or always trying to challenge how a metric is defined from the bottom up, or are the time period, the seasonalities are all things that could have happened or could happen in different scenarios. Any other question? Okay, so I'll jump to like another. So this part is the one that I'm doing in the course in the first part, on the business analytics part, because you see, and also this shows a bit the danger of Google Analytics sort of tools. That if you just use Google Analytics of business intelligence tool, you just see this visualization part, but you might not know like all the context and kind of challenge from that. The second example to show some paradox is, well, it could apply to all of this, but I think it's mostly, I think it's more like a warning if you work with SQL, you work with database. Also if you have reports, but also it's kind of a warning sign of how to write SQL. And again, that's a real case. I've always been passionate about the real estate sector, even before I was working for GFI. And I was following an index from a company called Homelet. It's not very famous, but there is a lot of reports in the newspaper about house prices and trend on house prices. But there is a bit less on a bit less on rental indexes and rental prices. But the same concept could apply to house prices, like here. I'm simplifying here, but again, that was a real case. It's probably still there in their website a few years ago. Basically, what the company does is that every month is publishing two things. One is an index on each region, and then the percentage change of that index from the previous month. And then it does by region, and then it does the total, UK-wide. And let's just simplify here. Let's say we have, let's do by year, it is easy, like 2015, 2016, 2015 and 16. And let's take just a few random regions. Let's take, we take Southeast, we take Southwest, we take Scotland, and we take Wales, just as an example. And then let's assume that we don't have only 4 regions, but we have a comprehensive set of regions. So here I'm just simplifying. Then we have a UK-wide figure. And the index, again, I mean, here would be on rental, but let's do on house price, because it's the same concept, it's just easier to explain. Let's say that the average house price in this region, let's say that Southeast here was 80, and then here was 79. Southwest maybe it's a bit less, maybe it was 70 and 58. Scotland, you know, maybe 65, and goes down to 62. Wales, you know, can be 52, go down to 49. Oh, I forgot London. Then we have London. Of course, London house prices are higher, so we had 140, and 2016 is 139. Right. And then here was the percentage term, percentage variation. Right. I'm not computing here the percentages, but it was all clear that all this was like negative, right? Negative, 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 and negative, right? All negative, some smaller, some bigger. And then we have a UK-wide, the average of all these that, you know, let's say that it is, make it easy, like 100. And what was here? 101. So it was positive. So I saw that report like that as a customer, and maybe I thought, okay, this company is kind of a small company. Maybe they've done a mistake. I don't know, they just published this. I don't know, I was just reading that because I was curious, but maybe not a lot of people read it. Maybe there was a junior analyst who was in a rush and just published this by mistake. And then I wrote to them. And when they tried to refer, we had a few email exchange because I just was a customer. When I wrote so many emails that when eventually they sent me the full database because they were so annoyed by my questions. And when I tried to explain that, and then I've also seen, and actually that was correct. There was no obvious, but even no reasonable in their view and in my view. And I think it makes sense. I mean, no obvious, reasonable mistakes in that data. So based on their calculation, that was actually correct. So you're doing the percentage here, and this was positive. So no data mistakes, no calculation mistakes. That was, and these figures were actually correct, and these percentages were correct. How could that happen?
So UK is the aggregated of?
Yeah, here we assume that all of them sum to UK, yeah.
So it's just a sum. How can it be higher?
I think you're going to the right direction. So you are trying to define. Maybe you can expand on this. What it means is just the sum. The sum of what? Or maybe you can go. Because again, I think that's going to the right direction.
Does Southeast include London?
Okay, yeah, again, no, this is Southeast without London. So let's assume that, yeah, this is all sum gives to the UK and no overlap. So it is a proper, yeah, it's a proper set. Yeah.
So maybe there was just more transactions in London than in other regions, so it drove up the average price for the UK.
You got exactly this time. You guys have been quick, exactly. And maybe let's try to do one step back to kind of go to that, and which also goes to that point, which how is that calculated? So maybe let's start for this. Let's say that you want to calculate the average house price in London. How would you calculate like the average house prices of last month? Which sort of data would you have? You don't have this, right? Which are the data points that you think of intuition, you think that you might have?
Well, you could take the last price a house sold for, so
yeah.
it might be 5 years ago, and then index it up to today, and then sum all those up and average them.
You could. That would be a more sophisticated part. But let's say that here is even more simple, that you are just doing the average of what was actually sold. So you're not doing a modeling. I think that thing's the thing, like if you go to Zoopla or Rightmove, you to have an index, and these are the sort of index that you have there. But this is more like, I don't know, you look at the monthly report from Nationwide, like how can they tell that the prices of last month have gone up and down? I don't think that but in that case they do modeling. They do a very simple thing. Right? What a bank has, like as an example, right?
Mortgage data.
Mortgage data, right? And mortgage data relates. So they know. So what does the mortgage data gives? It gives a price and gives the transaction, right? So in that case, we wouldn't look at the transaction a few years ago. We would just look at this transaction. So the data point, again, to get to this level, we need to start from here, right? the data is the transaction, because the unit is someone buys and someone sells a house. So that's the transaction. And what's the average? It's easy, right? It's just the sum of the transaction divided by the total number of transactions, right? And then you do this for all regions. But and then that's the point, but you don't know how many of those transactions there are. So when you try to aggregate by the UK, what you do, and I'm not saying that that's the only way to do it, or maybe not even the best way to do it, but you just sum all transactions, right? All transactions in the UK. You say that you even forget about this. You don't care about region-wise. You just want the UK house price. Someone is asking you, what is the average UK house prices of last month? You take all transactions of last month, right? And you take the average of that. That's the average of last month, right?
Well, I don't know if it was explained there, but if one year you were selling only expensive houses sold, and then the next year only one-bedroom flats sold, they're not like for like.
Exactly. That's exactly. In that case, it was by region. You could do the same exact thing by house type. You could do the same thing. You have flat, 1 bedroom, 2 bedroom, 3 bedroom, and 4 bedroom. And you could see that all houses by house type go down, but on average they go up. Why? Because the transaction on 5-bedroom houses, it was more common, so it's giving more weight. So in that case, it would have been there. Or maybe here, I mean here, the obvious one was that there were more transactions in London, but it could have been the same thing that even in London we are selling, or even in London we are selling like a more 5-bedroom houses than 1-bedroom house. So there can be different dimensions here. But the key point is how we aggregate from bottom up, like how we find the metrics. And I'm not saying that this is necessarily wrong. Like there can be ways to tackle that, and you can do like, you can see this variable like region, number of bedrooms, type of house, some other variables, and maybe you can try to weight and normalize. There are a few ways to limit that, but the problem is that to couple with this effect, you need to make an assumption, you need to make some work here on the business side. You need to think of, I don't want to have this positive, I want to have this negative, so maybe I take an average proportion, maybe I give an even weight to London. I keep the weight for each city as was last year, and things like that. So there are ways to tackle that, but it's just one way, and it could easily be misled from here. And the reason why I'm showing here in the SQL part is because these are the sort of things that you can easily get wrong doing things in SQL. So really, this line here is an SQL line, an SQL code of 3 lines. So like select average house prices grouped by, in this case, city, and in this case, you just do the average. So it would be 2 lines of code. So it could be a very easy thing that you could understand and couple and handle if you do in SQL.